All right, today on Algebra Cafe, we're going to talk about parallel and perpendicular lines. First, remember the slope formula. This works whenever you have 2 points, which we usually call x1, y1, and x2, y2. So for example, if you have the point 2, 1 and the point 4, 5, you're going to want to label those x1, y1, x2, y2, and then to find the slope. The top part of the fraction is always the y's. So you're going to do y2 minus y1 on the top part of the fraction, and x2 minus x1 on the bottom part of the fraction. So y2 is 5, y1 is 1, x2 is 4, and x1 is 2. Then I just simplify. 5 minus 1 is 4. 4 minus 2 is 2. This simplifies to 2. So the slope is 2. You can also write that as 2 over 1, if that makes more sense to you. So, getting to the parallel and perpendicular part, lines are parallel if they have the same slope, and they are perpendicular if the slopes are opposite reciprocals. So, suppose we've got a line y equals 2/3 x plus 4. A parallel line might look like y equals 2/3 x plus 7. A perpendicular line might look like y equals negative 3/2 x plus 8, say. This could be anything over here, as long as this is not the same as this, because that would make it the same line. Often, though, we are asked to find a parallel line that goes through a certain point, or a perpendicular line that goes through the same point. So let's do an example like that. So suppose we begin with the line y plus 2x equals 4. And we want a parallel line that goes through the point -1, 2. The very first thing we have to notice here that this is not in slope-intercept form. This is not in y equals mx plus b. So I'm going to convert it. By subtracting 2x from both sides of this equation. So now I've got y equals negative 2x plus 4. Here's the slope, negative 2. So my parallel line is going to go through this point. So we're going to have y equals negative 2x plus something. I'm going to go ahead and do this both ways, both with point slope form and slope intercept form. I'll start with slope intercept form because I've got it written that way already. So this missing piece, that's usually called the b. Now I also know that this point has to make this equation true. So this is my x value. I'm going to put that where the x is in the equation. This is my y value. So I'm going to put that where the y is in this equation. That's going to help me find this correct missing value. So I have 2 equals negative 2 times negative 1 plus b. 2 equals 2 plus b. Oh, so that means the b must just be 0 in this case. So my final equation is y equals negative 2x plus 0, or you could just write y equals negative 2x. Let's plug in this point again and make sure this really works. If we plug in negative 1, do we really get out 2? Yes, we do, so that works. We've also talked about using slope-intercept, or sorry, point-slope form, which looks like y minus y1 equals m times x minus x1. This is handy whenever you've got a slope and a point. So going back to that previous example, remember we had the slope, we wanted it to be negative 2, and we had the point, we wanted it to be negative 1, 2. So all we've got to do is put the slope where the m goes, and the point, the x value goes with the x1, the y value goes in the place of the y1. So this is going to be y minus 2 equals negative 2 times x minus a negative 1. And to simplify that, we would normally just write y minus 2 equals negative 2 x plus 1. And that is in point-slope form. Now, if we wanted to write the equation of the line that was perpendicular, we would do the same thing, except use the m as the opposite reciprocal, which will be a positive 1/2. So we could do the same thing we just did up here. We would do y minus 2 equals 1/2 x plus 1. With those hints, you should be able to do your parallel and perpendicular review, which is this paper right here.